Salam, peace be upon you. My name is Mohammed Layiq Sediqi, the father of Holophase. Part 37, Representation and Canonical Form. Same story, different writing. Remember the language we are learning. There is one field, phi, the holophase, one continuous cyclic movement from which all of reality unfolds. When phi begins to change, its first derivatives appear, and with them, the three dimensions show themselves at once. Time as omega, space as k, and motion as v, built from both. Every higher derivative is a finer question about how phi changes, and each one casts three shadows together: a time shadow, a space shadow, and a motion shadow. These echoes mix and weave into one another, forming the patterns we call fields, particles, bodies, thoughts, and worlds. In this picture, everything that exists is a living tapestry of phi, endlessly echoing through its derivatives and their dimensional shadows. Today, we listen to just one of those echoes. We now continue our profound journey through Episode 8, the pure abstract language of the Holophase Audio Series, moving to Part 37, Representation and Canonical Form, in Book 8.10, Representation and Canonical Form. Up to now, it felt like we had finished Episode 8. In Part 36, we climbed to the peak of abstraction. We understood how phi can begin to know itself from the inside. We completed the bridge to physics, at least in principle. It would be natural to say the chapter is closed. But as often happens when a structure is complete, a deeper pattern becomes visible. Once the scaffolding is taken away and we stand back, we notice something extraordinary. Our entire cathedral of ideas, carefully built from phi and its derivatives, has a hidden property. It can be written in many different ways and still remain the same cathedral. This is not about telling different stories. It is about the same story being written in different scripts, spoken in different accents, played in different musical keys, yet staying recognizably the same. It is about representation. Today, we explore a fundamental freedom in the phi language, the freedom of representation, and the search for canonical form. We will see that the universe, as written in phi, does not belong to any single mathematical dialect. The same reality can be described in infinitely many coordinate systems, units, and notations. The patterns of phi live on the underlying manifold, not inside any particular description we choose. Our goal is to understand this freedom, and then to ask a beautiful question. Is there a most natural way to write the story? A canonical form that shows the essence with the greatest clarity. 1. The core story. One meaning, many script forms. Imagine you have a simple but powerful sentence that carries deep meaning. For example, all things are connected. If you speak English, that might move you in a certain way. If you speak Arabic, you might say كل الأشياء مترابطة. If you speak French, you might say toutes choses sont reliées. Different words, different alphabets, different sounds, but the inner meaning is the same. Now take a whole story, a story about friendship, loss, and redemption. You can write it in English prose. You can translate it to Dari or Pashto. You can turn it into a poem. You can make a film. You can even express it through music or dance, without any spoken words at all. The surface changes, but the inner narrative and emotional structure remain. This is how representation works in the holophase view of reality. The actual universe, the relations between events, the way patterns of phi influence one another, the way time, space, and motion are woven together, is like the story. Our coordinates, units, and mathematical formalisms are like the languages, scripts, and art forms. They are different ways to express the same underlying content. If you move a camera to a different angle, the image on the screen changes, but the scene in the room is the same. If you change the musical key of a song, the pitch pattern shifts, but the song's identity is preserved. Representation and canonical form are about recognizing that difference and about learning to see through the surface into the invariant content beneath. 2. The linguistic role. Dialects and the original poem. In our language metaphor, representation is like having many dialects and many writing systems. Canonical form is like the original poem from which all translations are made. We already know that phi is like the underlying meaning. Derivatives of phi are like the grammatical ways of combining changes and asking more refined questions. Now imagine that we have several mathematical dialects for writing those derivatives. We can describe space and time in Cartesian coordinates using x, y, z, and t. We can use polar or spherical coordinates using radius and angles. We can follow curved coordinate grids that wrap themselves around complex shapes. All of these are different alphabets and grammars used to write the same phi field. In each dialect, the explicit symbols and formulae look different. A derivative might have a different expression. A wave might be described by different functions. A curvature might be written with different components. Yet the underlying relationships, the actual geometric and physical content, remain exactly the same. The canonical form is our attempt to find a representation that feels like the cleanest, simplest, and most revealing version of the poem. It is not that other translations are wrong. It is that some ways of writing make the essence obvious, while others hide it behind clutter. Think of a poem that is closest to its author's original voice, before being adapted for different stages and audiences. That pure voice is what canonical form tries to capture for phi. 3. Scientific essence. What stays the same when we change our description? The scientific heart of representation theory is a very simple but powerful question. What stays the same when we change how we describe things? Consider a physical situation as a concrete example. There is a tree standing in a field, and there is a flagpole in the same field. The tree is at some specific place relative to the flagpole. That relation, the distance and direction from one to the other, is a fact about the world, about the pattern of phi in that region. You can describe that relation in Cartesian coordinates. The tree is 3 meters east and 4 meters north of the flagpole. Or you can describe it in polar form. The tree is 5 meters away at an angle a little above 45 degrees. The numbers change, the words change, but the physical relation does not. The invariant content here is the actual distance between the tree and the flagpole, and their actual positions in the manifold of space. All coordinate systems are different ways of labeling the same underlying geometric facts. The phi field lives on that manifold. Our coordinates are just labels we paint on it. This idea extends far beyond simple geometry. In Newtonian mechanics, you can describe the motion of a planet in a particular coordinate frame and get one set of equations. In Einstein's relativity, you might choose completely different coordinates, perhaps ones that flow with the gravitational field. The equations look different. The symbols change. Yet the predictions about where the planet will be at a given time, relative to the actual stars and planets, are the same. In the holophase picture, this tells us that what is real is not any particular formula, but the web of invariant relations among phi and its derivatives. Representation is a choice of clothes. Reality is the body underneath. 4. Dimensional expression. Freedom across time, space, and motion. Representation freedom does not only apply to space. It plays out across all three-dimensional echoes: temporal, spatial, and motional. In time, we can choose different ways of measuring and labeling duration. We can measure in seconds, minutes, hours, or years. We can also choose different time coordinates in our equations, especially in relativity, where one person's time coordinate can be a mixture of another person's space and time. Yet the causal order of events, the proper time along a path, and the durations measured by an ideal clock traveling with an object are invariant. The plot of the story does not change when we change the numbering of the pages. In space, we can choose different units of length, different coordinate shapes, and different ways of slicing the manifold into here and there. We can draw grids that are straight or curved. We can stretch and compress our coordinate axis. The underlying spatial topology, what is connected to what, how many holes or loops space has, remains invariant. The setting of the story does not change when we redraw the map. In motion, we can describe velocities and accelerations relative to different reference frames. A person on a train sees a drop ball fall straight down. A person standing next to the track sees the ball follow a parabolic path. Yet both can agree on invariant quantities like the proper time along the ball's path or the laws governing its motion. The action of the story is the same, even when filmed from moving cameras. In all three echoes, there is a deep distinction between the choice of description and the invariant content. The holophase language is built so that these invariants live naturally in the structure of phi and its derivatives. Representation freedom is built in from the beginning. V. Position in the master tree. Different views of the same branches. Where does representation sit in the master tree of phi? The tree itself is the actual structure of reality written in phi. Total energy, derivatives, topology, holonomy, wave patterns, and so on. These are like the living branches and leaves of a real tree. Representation theory is less like a new branch and more like the different drawings and photographs we can make of the tree. You can sketch the tree from the north side and catch the outline against the sky. You can photograph it at sunset and emphasize shadow and color. You can make a botanical cross-section showing the rings in the trunk. Each representation reveals something and hides something. None of them is the tree itself. In our framework, the same is true for mathematical descriptions. Working in one coordinate system may make the wave structure of phi look simple, but hide the topological twists. Another system may make curvature obvious, but obscure simple straight lines. Representation theory teaches us to treat these not as competing realities, but as complementary views of one reality. Canonical form, then, is our attempt to find the view, or perhaps the family of views, that best balances simplicity, completeness, and clarity. It is like choosing an angle and lighting for a photograph that reveals the structure of the tree in the most informative way. 6. Relations to neighbors. Representation across all structures. Every major structure we have discussed in the holophase language shows its own version of representation freedom. Derivatives of phi, for example, become ordinary derivatives in simple coordinates and more complicated covariant derivatives in curved coordinates. But what they represent, how phi changes as you move along the manifold, is invariant. It is the change of phi that matters, not the particular symbols used to write the derivative. Topological features, like loops and knots, are the same whether you draw them on squared paper or on a curved surface. The number of times one loop links another does not depend on how you stretch or squash the picture, as long as you do not cut or glue. The linking number is an invariant. Holonomy, the memory of a path encoded in phase, does not depend on how you parameterize the path or what coordinates you use. The total twist you gain by going around the loop in the field is a property of the actual loop and the actual field, not of your description. Quadratic forms, such as the length of a vector, the energy of a state, or the space-time interval, are deliberately built to be invariant. They are scalar quantities, single numbers that every representation must agree on. In relativity, the space-time interval between events is the same in all frames. In the holophase language, analogous quadratic structures carry invariant meaning across coordinate changes. Spectral decompositions, where we break a pattern into simpler modes, also show representation freedom. You can use sine and cosine functions as your basis, or you can use other families of functions adapted to your problem. The pattern being represented is the same. You're just choosing a different alphabet for your harmonic description. This web of examples teaches us to separate the canvas from the painting, the notation from the pattern. Representation theory is the discipline of honoring that separation. 7. Semantic meaning. The work of representation and canonical form. Why does any of this matter? What work does representation freedom actually do for us? First, it allows us to simplify problems. Some representations make a complex problem almost trivial. For example, rotating coordinates so that one axis points along a symmetry direction can collapse a messy set of equations into something much simpler. In the holophase context, choosing the right representation can make certain aspects of phi structure almost obvious. Second, it protects us from being fooled by our own descriptions. When we know that different coordinates can make the same phenomenon look different, we are less likely to mistake a coordinate artifact for a real physical effect. We learn to ask, does this quantity change if I change coordinates? If it does, maybe it is just a feature of my description. If it does not, it might be a genuine feature of phi. Third, it guides us towards deeper unification. Often, two theories that look different in their usual representations turn out to be the same when expressed in a more suitable canonical form. Recognizing that unity requires us to see past superficial differences of notation, units, or coordinate choices, and to focus on invariant content. Finally, the idea of canonical form invites us to search for the most natural expression of the holophase language itself. It encourages us to ask what set of variables, equations, and structures most directly reflect the behavior of phi. This is not about finding the one true representation and rejecting all others. It is about finding a reference form that anchors our understanding, from which all other representations can be seen as translations. 8. Stability and falsifiability, when representations must agree. Representation freedom also leads to a clear falsifiability condition for any physical theory built from phi. If two honest representations of the same situation, correctly related to each other, predict different experimental outcomes, then something is wrong. Either the transformation between the representations is wrong, or the theory violates the principle of representation invariance. In practice, physicists use this all the time. They perform calculations in one coordinate system, then check the same result in another. They transform equations from one frame to another and see whether the physical predictions match. If they do, the underlying theory shows representation consistency. If they do not, there is a mistake either in the theory or in the transformation rules. In the holophase program, this principle is sharpened. Phi lives on the manifold itself. Any legitimate coordinate system is just a way of charting that manifold. Therefore, any physically meaningful quantity must be expressible in a coordinate-independent way. Experimental outcomes must not depend on our choice of labels. If ever we discover the phenomenon whose outcome changed with a mere rescaling of coordinates or a smooth relabeling of positions without any physical change, that would challenge the entire geometric and holophase picture. It would suggest that coordinates themselves have hidden physical content, which would be a profound and surprising result. 9. Examples across scales, seeing representation everywhere. You can see the idea of representation and canonical form in action throughout everyday life. Think of temperature. You can measure it in Celsius, Fahrenheit, or Kelvin. The numbers are different, the 0 point shifts, and the scale stretches or compresses. Yet the basic facts, whether water freezes, whether you have a fever, whether a metal expands, do not depend on which scale you choose. The sensible canonical form for thermodynamics uses Kelvin because it aligns naturally with energy and entropy, but all scales represent the same underlying thermal reality. Think of money. You can count prices in dollars, euros, or pounds. Exchange rates change the numbers, but the purchasing power and the physical goods involved are independent of the currency used to describe them. Economists sometimes choose a real unit, adjusted for inflation, as a more canonical measure of value across time. Think of distance on Earth. Different map projections represent the globe on a flat page in different ways. Some preserve area, some preserve shape, some preserve direction. No flat map is perfect, because the Earth is curved. Each projection is a representation, emphasizing some aspects and distorting others. A canonical form here might be the globe itself, the actual curved manifold from which all maps are derived. Think even of your own identity. You can describe yourself by your name, your passport number, your social role, your occupation, your personality, your values. Each is a representation of something deeper, the living pattern of experiences and actions that make up who you are. No single description exhausts that reality. Together, they give a richer picture. Representation and canonical form invite us to constantly ask, what is the reality behind this description, and how many other ways could it be faithfully told? X. Human analogies. Same relationship, different faces. A simple analogy from human life can make this even more intuitive. Imagine a friendship. Two people care about one another, support each other, and share history. That core relationship can be represented in many forms. Legally, it might be invisible. There is no contract. Socially, it might be called best friends. Emotionally, it might be experienced as warmth, trust, and mutual recognition. In a photograph, it might appear as two people laughing together. In a series of messages, it might appear as long conversations. All these are representations of the same underlying relationship pattern. No single representation is the relationship itself. The relationship lives in the ongoing pattern of interactions and feelings between the two people. In the holophase metaphor, phi is like that underlying relationship. Coordinates, equations, and formalisms are like the photographs, messages, and labels. Canonical form would be something like the pure description of the relationship's essential qualities, stripped of culturally specific packaging. 11. Recognition skill. Seeing beyond the symbols. You can train yourself to see representation and canonical form by gently detaching from specific symbols and looking for invariants. When you hear a scientific claim, ask yourself, is this about a particular coordinate choice, a particular notation, or is it about something that would still be true in many different descriptions? When you see a graph, ask what would stay the same if the axes were relabeled or the units changed. When you encounter two different explanations of the same phenomenon, look for the common pattern they might be expressing in different language. In your own thinking, you can practice rewriting the same idea in different forms, verbally, visually, mathematically, metaphorically. The part that survives all these translations is closer to the invariant core of the idea. The parts that change or disappear are features of specific representations. This is not just an intellectual exercise, it is also a form of humility. It reminds you that your favorite way of describing reality is one representation among many. It opens you to learning from other perspectives, other traditions, and other sciences, because you start to suspect that beneath different languages, there may be shared truths. 12. Return to phi. One story, many tellings. As always, we come back to the single field. There is one field, phi. It differentiates, generating time, space, and motion. It forms waves, structures, and topologies. It filters itself into stable, knowable patterns. It develops minds that can ask questions and build theories. All of this happens on the manifold of reality itself, independent of any particular coordinate grid or notation we humans may choose. Representation and canonical form teach us that the holophase language is not tied to any one mathematical style. The equations in the holophase papers, the diagrams in your mind, the words you're hearing now, all of these are representations. The reality they point to is phi, patterned in very specific ways. In the deepest sense, canonical form is not a single equation or a single book. It is the whole coherent structure of phi seen as clearly as possible, with minimal dependence on arbitrary choices. It is a kind of clarity in our understanding, more than a particular choice of symbols. With part 37, we have finally completed the abstract ascent of Episode 8. We have the language, the mapping, the filtering, the self-knowledge, and now the freedom of representation and the idea of a canonical voice. From here, we are ready to descend into physics. Not as people lost in equations, but as speakers who know that behind every representation lies one living story. That story is phi, writing and rewriting itself in endless forms. You are one of those forms. As you listen, reflect that you too are a representation of phi, a canonical expression of the universe at this place and time, carrying within you the capacity to understand and to tell the story forward. 13. gauge freedom, and everyday redescription. There is one more subtle level of representation freedom that is worth touching before we close, because it will matter later when we talk about forces and fields. This is sometimes called gauge freedom. It is the freedom to change certain descriptive choices without changing any physical prediction at all. A simple way to feel this is to think about measuring height. You can measure everyone's height relative to the floor in your room. You can also decide to measure everyone's height relative to the street outside, or relative to sea level, or even relative to the center of the earth. All the numbers change, but nothing physical changes. Who is taller than whom stays exactly the same. You have added or subtracted a constant offset, a pure redescription. In physics, something similar happens with many field descriptions. You can add the same constant to the electric potential everywhere, and no experiment changes. You can shift the overall phase of a quantum wave function by the same amount everywhere, and all measurement probabilities stay the same. These freedoms tell us that the potential itself is not the directly physical thing. What carries physical meaning are differences, gradients, and interference patterns, not the arbitrary zero level we choose. From the Holophase point of view, this is natural. The real object is always the phi field on the manifold, and the relations among its derivatives. Potentials, reference levels, and overall phases are like choosing where to put the zero mark on a ruler, or which direction you call up in a drawing. Canonical form, in this context, often means choosing a gauge that makes the structure of phi easiest to see, while remembering that other gauges are equally valid as long as they lead to the same physical predictions. You can see a similar pattern in everyday life. Think about money. If all salaries and prices in a country were doubled overnight, but every ratio stayed the same, nothing fundamental would change about who can afford what. The currency unit has simply been rescaled. Or think about loudness on a volume dial. You can choose 0 to be silence and 10 to be your preferred maximum. Or you can choose a different numbering. The ear cares about the actual sound, not the label on the dial. These are all small echoes of the deeper fact. Reality often depends on relationships, not on absolute labels. Gauge freedom is the formal version of this insight in our equations. It warns us not to mistake convenient human conventions for extra pieces of ontology. It reminds us, once more, to look through the writing to the story. As we move forward into more detailed physics, we will carry this lesson with us. When we meet different potential functions, different phase choices, or different coordinate gauges, we will ask, do they change any invariant, measurable relation among phi patterns? If not, there are different ways of saying the same thing. Representation freedom has done its work. Behind the shifting symbols, the same field is quietly speaking. In this way, gauge freedom becomes a gentle training ground for your intuition, teaching you again and again to separate shifting descriptions from the single, quietly enduring reality always already beneath. Salam, and peace be upon you.